So in the video we will talk about isomerism, stereoisomerism type. Stereoisomerism is the isomerism due to the arrangement of molecules or groups with respect to each other in space. With respect to each other in space. That's the basic concepts of stereoisomerism. Right. What in 12th standard we are going to deal with. Right. Okay. We are classifying the stereoisomerism into two types. One is geometrical. Geometrical isomerism, otherwise called as cis-trans isomerism. Okay. Then another one is optical isomerism. Another one is optical isomerism. We will first deal with the geometrical isomerism. Right. So in coordination number 4, complexes having coordination number 4, there are two types of geometry. One is tetrahedral and another one is square planar. Super. So in tetrahedral geometry, you know that all the 4 bonds are having what angle? 109 degree 28 minutes. This is the bond angle. So it means that all the bonds are adjacent to each other. All the bonds are adjacent to each other. So there is no opposite positions or adjacent positions. So if two same groups are present in opposite positions means it is a trans isomer, and adjacent positions means it is cis isomer. So we cannot differentiate the 4 positions as cis positions or trans positions. So we don't have geometrical isomerism in tetrahedral complexes. Coming for square planar. So square planar complexes have a metal atom at the center surrounded by the 4 ligands which are all in the same plane. So square planar complexes of these type species have geometrical isomerism. For example, consider Ma2B2. M is the metal atom and A2B2. Since 2A similar ligands are adjacent to each other, it is called as cis isomer, and if the 2 ligands A and B are opposite, it is called as trans isomer. Okay, right. Similarly, A to B, you have to look up to the A, the 2A species. If they are adjacent, it is cis. If they are opposite, it is trans. Similarly, here it is XY means unsymmetrical bidentate ligand. Example, I will give you an example. Glycine A2. See here, it is from the amino acid glycine. So here nitrogen can donate a pair of electron and this oxygen can donate a pair of electron. If, see here, I will write the cis isomer only. It will be easy for you. See here, O minus, which is a donor. It is attached to CO and then CH2 and then NH2. Here N is the donor. Right. Again, see here. Here N is the donor and then CH2, CO. Here O is the donor. So here see both the oxygens are cis to each other. So it is called a cis isomer. If we reverse N here and O here, if we reverse the formula, if we reverse it as this, it is said to be trans isomer. Okay, right. Then coming for MABCD type. Here with respect to one ligand A, how the other ligands are situated. For example, I will draw you the structures of MABCD ligand. Look here. It is not at all a difficult one. It is also a same thing, but here the main thing is with respect to one isomer, we are classifying with respect to one ligand, we are classifying others as cis trans. So consider here it is A, B, C, D. Keep A as constant. Move the positions of B, C, D around maximum at move them for 90 degrees. So from B, here it goes. From C here it goes to C here and D comes here. So here adjacent to A are D and B. Here adjacent to A are C and D. Similarly, a third structure can be drawn for this isomer alone. So what is the third structure means? A, keeping A as constant there, again changing. So D goes here, B goes here and C comes here. Now adjacent to A are B and C. So in all the cases, adjacent ligands to A are different. So this formula especially has 3 isomers. Also, writing an example for a formula is not at all a difficult one. Consider M. Let it be. Here it is all square planar complex, right? So 4 ligand. What are the metal atoms that can accept 4 ligands as electron donors? Means platinum, nickel, cyanide, zinc. We can light a lot of ligands, right? You can consider platinum. For A, consider 2 similar ligands, let it be amine, and for B, consider 2 similar ligands, let it be chlorine. The charge of platinum is 4 plus. Here it is 0. Here it is 2 minus. So 4 plus 2 minus, it gives 2 plus charge. So this is the example for this complex. Similarly, we can write about the formula. Whatever the formula is, not it is nothing a difficult one. We can write the formula and we can write the examples. Right? Then coming for coordination number 6. If the coordination number is 6, then the geometry is called as octahedral geometry. Very good. So consider this as the octahedral geometry, in which 4 ligands are in one plane and the 5th ligand is above the board and the 6th ligand is below the board. Right? 6th ligand is below the board. Right. So we are going to look after 2 positions. If the 2 positions are adjacent, if the 2 similar ligands are adjacent, it is called as cis. If the 2 similar ligands are opposite, it is called as trans. Okay. Simple. Consider an example. Let me take a book for you to explain it as an example. Right. Consider this as a plane. So here the metal M is located and one ligand, second ligand is here, third ligand is here, fourth ligand is here. The 5th ligand is towards you. Okay. And the 6th ligand is at the back of the book. So the 5th ligand is towards me and the 6th ligand is away from me. Right. Consider this as position 1. This is the pen cap. Okay. It is the position 1. 2, 3, 4, 5 are there. Okay. Right. See here, 1 and 2 are adjacent. So this 1 and this 2 are adjacent. 1 and 3 are adjacent. 1 and 4 are adjacent. 1 and 5 are adjacent. So similarly, these are all adjacent positions. 1 with 2, 1 with 3, 1 with 4 and 1 with 5. Similarly, if we consider this as the 6th position, 2, 6 are adjacent, 3, 6 are adjacent, 4, 6, 5, 6, everything is adjacent. 2, 6, 3, 6, 4, 6, 5, 6. Then consider this, it is the 2nd, 3rd, 4th, 5th one, right? So 2 and 3 are adjacent, 3, 4 adjacent, 4, 5 adjacent, 5, 2 adjacent. So there are 12 cis possibilities, 12 cis positions, right? Then coming for trans. So the 2 opposite ones, 3 and 5, 3 and 5, 2 and 4, 2, 4, 1 and 6. These are the opposite positions. Okay, super. Come for the formulas. So here there are several compounds which exhibit geometrical isomerism in case of octahedral complexes. See here, Ma4B2 type, Ma3B3, Ma2B2C2, Ma4BC. I have listed all the things. Okay, see here. There are 6 ligands totally. You consider the 2 similar ones. Here it is B. So you take the 2B, 2 similar ligands. If they are in any one of these related positions, it is called as a cis isomer. If the 2B species are present in any one of these 3 arrangements, it is called as trans isomer. Consider one B here and another B here. What is it? Whether it is cis isomer or trans isomer? Sir, these 2 positions are adjacent to each other, sir. These are cis isomers. Very good. So consider, let the B be here. 2 B atoms are here. Sir, it is trans isomer because it is present in 1,6 trans position. Clear? Very simple one. Especially in this isomer Ma3B3 type. Ma3B3 type, we are going to classify this into 2 main special isomers. They are called as, one is called as spatial isomer and another one is called as meridional isomer. Meridional isomer. What is it, sir? See here. The metal is located at the center of the octahedral position and the 6 ligands are present at the axis. Okay. Right. See here, Ma3B3 type. I am going for, let me rub the optical. I will write again. Okay. I am going for Ma3B3 type. So if the 3A ligands are in consecutive position or in adjacent positions, see here, then the 3B positions will be like this. Okay. Now see, join all the A positions. Join all the A positions, right? Join all the A positions. I will get a triangle, right? I will get a triangle. So triangular face, I will get a triangular face by joining the similar ligand. So it is called as a facial isomer, right? See here, in the case of meridional isomer, look here, if any 2 ligand is present in trans position, See here, if A and A is present here, one of them are in trans relation, right? B is here. One of the B is in trans relation. If it is like this, join the 3A species. It will be passing through the meridional axis. So constituting a semicircle. Okay. So it is called as meridional isomer. So in case of geometrical isomerism of cis or geometrical isomerism, that is cis or trans compound. So these are the formulas which constitute the geometrical isomerism for square planar geometry, and these are the 2, 4, 6, 8 and 9. So these are the 9 formulas which constitute the geometrical isomerism, that is cis and trans form for the octahedral geometry. Clear? Shall we go on for the optical isomerism? Yes. Right, now we are going to discuss about the optical isomerism. Okay, what is the essential condition? You all know what is optical isomerism. So when a substance, when a plane polarized light is passed through certain substances, the light will be vibrating in a different plane. It may be in a clockwise direction, dextro-rotatory, or anti-clockwise rotation, levo-rotatory. You are all very well know that, right? Why a compound exhibits optical isomerism means the essential condition is what? Chirality. What is chirality? That the molecule should be asymmetric. Asymmetric, it should not have any plane of symmetry. Then also it must be having non-superimposable mirror image relation. So those isomers are called, non-superimposable mirror image isomers are called what? Enantiomers, right? Coming for the coordination number 4, there are 2 types of geometry, tetrahedral and square planar. In tetrahedral type, this type of complex alone exhibit optical isomerism because the remaining type of species will have plane of symmetry. Similarly, in square planar complexes, all the types will have axis of symmetry. So they won't exhibit optical isomerism. Coming for coordination number 6, which is octahedral. So there are several types of complexes, enormous amount of complexes which exhibit optical isomerism. Right. Let us go through an example. Consider this example: cobalt with 3 species molecules of ethylene diamond with a 3+ charge. Look here, the central metal atom cobalt, it is hexadentate. It is having octahedral geometry, right? So let it be one ethylene diamond species, let it be another, and this one the third one, right? When we are having mirror image relation, when we are taking mirror image for this compound, cobalt, so with the, right, look here. So what the ethylene diamonds will be here, and a molecule will be present, and here one of the ethylene diamond will be present, and here one of the ethylene diamond will be present. So among these two, one will be dextro-rotatory and another will be levo-rotatory, which are generally called as enantiomers. So it is nothing but like the right hand, which on the mirror you will observe the left hand. So they are having non-superimposable relationship. They cannot be superimposed over one another. So such kind of isomers are called as enantiomers. So that is the topic related to optical isomerism is very much constricted in our topic. So this is enough for our state board or NCERT syllabus regarding the optical isomerism in coordination compounds. Hope you understand. Thank you.